Hi everyone. Today, let me solve this problem. This problem is still a thermochemistry problem. Okay, so let's look at the question. The question is asking if we have the sodium hydroxide added into the water in a calorimeter, and we know the initial temperature and the final temperature, and also we know the specific heat of this solution. So what's the final? Determine what's the heat released during the solution process. Well, this is kind of like a calorimeter question, but instead of a metal, but this is a solution. So we have a calorimeter, and this is the isolated system. This is the isolated system. Okay, so we have sodium hydroxide, put it into the water. And what happened? The sodium hydroxide will release the heat, will generate heat. Okay, so the sodium hydroxide, when they react with water, it will release heat. Okay, so once it's released the heat, what happened? The solution, the solution, the temperature will increase. Okay, yeah. So in general, we can use the equation like that. The Q of the sodium hydroxide solution. Okay, so sodium hydroxide react with the water can be, this is the energy released, is equal to the what's the energy absorbed. The energy absorbed, which one absorbed the energy? The solution, the final solution is absorbed the energy. Okay, and this is the solution absorbed energy, and this solution can be write as the C specific heat of the solution time the mass of the solution and time the change of the temperature, which is the final temperature of the solution minus the initial temperature of the solution. Okay, let's see whether we have those parameters. I recommend you write down the parameters on the side, so you will find, this is pretty neat. So the specific heat of the solution, do we have the specific heat of the solution? I think we do. That's in the question, which is 3.89 joule per gram per K. 3.89 joule per gram per K. Okay, do we have the mass of the solution? The mass of the solution, I think we do. The mass of the solution, we have the mass of the water and the mass of the sodium hydroxide. When the sodium hydroxide dissolves in the water, and the solution is the total of the mass of water plus the mass of the sodium hydroxide, which is 100.0 plus 10.0 gram. So the total is 11.0 gram. Okay, and do we have the final temperature? The final temperature, I think we do. The final temperature is 48.2 Celsius, and the initial temperature is 24.0 Celsius. It's 48.2 Celsius, and the initial temperature is 24.0 Celsius. 24.0 Celsius. Okay, then you put all the numbers into the equation. into this equation, then you will find the heat generated by the sodium hydroxide and water. So this can be the negative sign. We have a 3.89 joule per gram per K. And the time, the mass, which is 110.00 gram. And the time, the final temperature minus the initial temperature. The final is 48.2 Celsius minus 24.0 Celsius. Okay, and then you put everything into the calculator. That's going to be 3.89 negative time 110.00 time parenthesis 48.2 minus 24.0 parenthesis. Okay, so the total is negative 10355.18. Negative 10355.18. And the unit is a joule. Okay, and then let's go back to look at the sig fig. This is a 5 sig fig, 4, 3, and 3, and 3 here. So the final number gonna be 3 sig fig. So what we have is keep this, and this, and the number will be negative 10400 joule. Or you can write like a negative 1.04 times 10 to the 4th joule. Okay, so those both are right. Both are okay. Okay, and also we have a negative sign, which means this is exothermic reaction. It's an exothermic reaction. It is the exothermic reaction because it generated the heat. Okay, so this is the problem solving for this question. Okay, I'm glad you look at this.